Welcome to EDU World Space.
And this problem is kind of actually interesting because we're given the equations and then basically asked to construct the system that those equations would be derived from. So we're told that we have a farm gate that's supported by two hinges on the left side, and a bucket of grain is hanging from the latch. So I just kind of represented the gate as kind of a triangle here. Maybe there's an extra piece here, I don't know. But then the weight, the basket of grain is, the bucket of grain is supported over here. And then we're told that, we know that so we have three components, or three force components in this problem, A, B, and C. So we're told that minus A plus C equals 0. Well, that's a balance of forces, and I said that, okay, if this is C and this is A, then in the horizontal direction, minus C must be equal to A. And I've drawn, this should be an arrow over here and not on the other side. So that it is minus C. So minus C plus A equals 0 is the force balance in the horizontal direction. We're also told that B minus 392 minus 50 newtons is 0. So that's a force balance in the vertical direction. So that must be the force at one of these hinges. Or basically, we can't resolve what the force on each hinge is, but we can resolve what the net force on both hinges are, or just assume that one hinge has a vertical force and this one is free to slide up and down. So that basically tells us what the weights are. So the weight of the gate itself is 392 newtons, and the weight of the bucket is 50 newtons. Now the last equation is the moment equation, and we can know that because we can see that the terms are moments and not forces. And so the first thing is we have A times 0 plus B times 0, and that means we're taking moments about this point. Okay, so that the equation A and B, the force components of A and B at this point drop out, or if B were down here, it would still drop out. So we know we're taking moments about that point, and so we can see that C acts at a distance of 1.8 meters. So that must be this distance here. So D is 1.8 meters. Whatever weighs 392 newtons, which I assumed was the gate, acts at a distance of 1.5 meters. So that's this. And then the basket, or the bucket, which I assume weighs this much, acts at a distance of 3 meters. Okay, so that would be the total length of the gate. Right? So it wouldn't make any sense for these two weights to be the other way around, because we're told that the bucket is what is at the end of the gate. So then they ask us to solve this. So we have three equations and three unknowns, and we can just do some algebra, and we get obviously that A equals C, and they are both 410 newtons, and then we can find B, and that is 442 newtons.